check if this element in A is greater than the last element in A. So, A of n minus 1 will be the last element in A, and A of I will be A of 0, A of 1, A of 2, and so on until the second last element. We obviously don't want to compare the last element with itself. So if that's the case, we'll just say, yeah, uh, you can't satisfy this condition, so you'll break out of it. So I hope that answers your question. This is where we are, so basically this is where we are checking that even array A satisfies the condition. We know that array B satisfies. This is where we'll check whether array A satisfies the condition. And if it does, we'll print yes, or else we'll print no. So I hope that's clear. So yeah, you guys can scan the attendance form. I'll give you guys a couple of minutes. I hope it's visible. So yeah, all right. I hope all of you have filled the attendance form. Don't worry, the attendance form will be shown at the end of the session as well. So for now, we've reached the conclusion of the session. So as you might have noticed, greedy approaches are closely related to your intuition. You, it's like when you're given a problem, the greedy approach would be the first thing that you think of. So it's closely related to intuition. So whenever you come up with a problem, you need to come up with test cases to find out whether the greedy algorithm will work. So obviously it'll fail even if there's one test case. If it doesn't work, then that means the greedy algorithm fails. However, if you're not able to come up with a counterexample, then you can, during a contest, you wouldn't have time to like mathematically prove that the greedy solution is indeed correct. So during a contest, you can go ahead with it. However, as mentioned, mathematically proving that a greedy solution will be the correct solution can be a bit more challenging. That will involve some math, and so that's a bit more complex. We're not going to go into that for now. But yeah, I hope this you guys will learn something about the greedy approach, especially the importance of coming up with test cases on your own. So yeah, we've come to the end of this session. I thank you all for listening, and please fill the feedback form. I'll wait for a minute or so. So I guess all of you have scanned the QR code. So yeah, that marks the end of the first part of the session. So now Advik will be covering brute force, which is another common topic that you'll encounter in your brute forces problems. So yeah, thank you all. I'll stop sharing my screen now.
Hi everyone, I'm Advik. I'll be taking the session for brute force now. Hold on for a minute while I share my screen. Okay then, I'll start. So brute force is in one way like the easiest method you'll think of. It's just testing every single case one by one. So the definition would be to solve the problem by trying every single possible solution until you hit a solution. So it's not a very sophisticated solution. Usually, you will just be trying to just try every single combination or every single number until you find something which can help you get the solution. So it's very simple and straightforward, and usually the first thing you'll think of, and it's applicable in almost every problem because there is usually a way to brute force the answer. Like, say, you need to find a password, you can start testing every single letter from one letter to 1,000 letters and see when you find the correct password, but that will take a very long time. So that's an example of brute forcing. This is one of the earliest problem solving methods because of its simplicity. So now I'll go over to the advantages. So it's very simple to use, very easy to understand. It's the first thing you'll think of, and it guarantees finding the correct solution. So in some algorithms like greedy, which Anton just did, you don't know for sure if you're going to find the correct solution without doing a bit of proving beforehand. But brute force guarantees that you'll always find the correct solution. And it's very useful for small problem sizes. If the problem size is small, you don't need to try any complicated solutions, and brute force will usually work. And it's preferred if the sample size is small. So now, mainly disadvantages. You have to remember that brute force algorithms are usually very time consuming and computationally expensive. This is why a brute force is not something you can use in every single problem, because they will take a very, very long time. Usually, it could go up into years and decades sometimes. Like in my password example, brute forcing a normal password in modern day could take billions and billions of years. So it's a very time consuming method. And for most problems, brute forcing is not a very ideal solution because you can usually get a faster method using other techniques. And it's not very practical for large inputs, again, due to inefficiency. So brute force usually will have an exponential time complexity. So that just means that, if it's 10 elements, it might take 10 seconds, but for 100 elements, it might take 1,000 seconds, and stuff like that. For 1,000 elements, it might take 1,000,000 seconds. So yeah, that's the basic run through of brute force. It's a very simple algorithm, and it's not like one size fits all. Like, you have to think of the brute force approach. So I'll give some examples. So here, given an array and a target sum m, can you find two numbers which sum up to m in the array? So you have an array of, say, 5 elements, say 1, 2, 3, 4, 5, and you need to find two elements which add up to 7. So you can, think of ways so that you can find two elements such that their sum is 7. So I'll stay here for 30 seconds while you think of answers. Okay, fine. So yeah, I saw an answer in the chat. So yeah, essentially you can make two for loops such that you find two elements and their sum adds up to m. So here there are some things you have to keep in mind, that I am starting from I plus 1 and not 0 again. Can someone say in chat why I'm starting from I plus 1 and not from 0? Yeah, that's also a valid solution to create a copy of the array, subtract elements from M and look for common elements. That is possible. That is a solution. Indices repeat again. Exactly. Yeah. So you don't need to check from zero to the size again, because then you will be checking everything twice, which is not required. So you go, you set the first element. So this first loop kind of sets the first element. So 0 till the size. So say now the first element is set. Now you'll check from the second till the last element and check if the sum adds up to m. Or else next one the first element, and then the third no next one will be second element and the third to the last element. So in our 1, 2, 3, 4, 5 example for 7, so this would go 1. So 2, 3, 4, 5, none of them add up to 7. Now it will be 2, 3, 4, both of those don't add up. So 2 plus 3 is not 7, 2 plus 4 is not 7, but 5. 2 plus 5 is 7. So now we have found two elements such that the it's, the sum is 7. So can you think of a more efficient solution? This is not in the portions for this lecture, but if I'll just wait for 30 seconds to let you guys think of a smarter solution. Um, no, the copy method will not be better in any sense. So it's not. There are some unnecessary so much. Okay, and how would you check? Hold on, look at the chat for a bit. How would you check if a number